recording? There we are. Okay. We are recording. We have 2 students here from WSSB and a student in Prineville. And it is Tuesday, November 5th, voting day. Get out the vote today.
Who's gonna be running?
Which is really bizarre. We haven't had a whole lot of stuff over in my neighborhood and in Oregon talking about the vote, but it's a voting day, so I guess we're voting. I didn't get a mail. We do vote by mail. I don't recall getting a mail. Maybe we don't have anything we're voting on. It's bizarre. I don't know. All right. We'll vote on math. So it says, get ready for the lesson. Popcorn.
Man, what's with all the food,
Popcorn.
right?
I know. What's with all the food today? Kip surveyed his class to find what kind of popcorn students like best.
Caramel.
The results of the survey are shown in the table. So we have a table of favorite kinds of popcorn. Buttered, 5 out of 12. Cheddar, 3 out of 16, 3/16. Caramel, 1/8. And plain, 1/6 of the class.
It's a tie between the 116 and the 112.
Do more or less than half of the students prefer buttered popcorn? Explain how you know. So buttered popcorn is 5/12. Is that more or less than half? Less. How do you know? How do you know 5/12 is less than a half? How do you know? It is less than a half. How do you know 5/12 is less than a half? What would half be?
1 and over 2.
Out of 12. 1 out of 12 would be half?
No, 1 over 2 would be half.
1 over 2 would be half. So what would that be in twelfths? What's half of 12? 6. So half would be 6/12, wouldn't it? So 5/12 is less. Correct. All right. So do more or less. So we know that less than half like buttered popcorn. Which category is preferred by more students? Caramel or plain? So caramel is at what? 1/8. Plain is at 1/6. Which is
1/8.
preferred by more students? Caramel or plain?
1/8. Caramel.
That's more?
6.
1/6 is more. If you sliced up a pizza, the same size pizza, so you have 2 large pizzas sitting in front of you, and you cut it up into 8ths, and then you cut the other one up into 6ths. Which would you rather have, an 1/8 of a piece or a 1/6 of a piece? The 1/6 of the piece would be bigger, wouldn't it? The less pieces you slice it up into, the bigger it gets. That's where fractions get a little funky for people to think about. Because when you think about 1 over 8, 1 over 6, 8
Is bigger than 6.
is bigger than
That's what I was
6
thinking.
as a whole number. As a whole number. But when we're doing division, when we divide things up by more parts, it's actually smaller, isn't it? Right? If we divide something up into 100 pieces, that's one little piece of 100 is way smaller than if we divided it up into 20 pieces, right? I'd rather have 1/20th of something than 1/100th of something. Does that make sense? Okay, so that's what you got to be careful with. And so it's always good sometimes to think about, oh, if I cut that pizza up, which would I rather have if I want a large slice? Not if you're on a diet. Okay, all right. Which category of popcorn is preferred by 1/4 of the class? 1/4. Which category of popcorn is preferred by about 1/4 of the class?
Plain.
The plain is close to 1/4?
Wait. No, it's the 6. Wait, no.
Which one's close to 1/4?
Caramel.
The caramel is an 1/8. It's actually the cheddar. 3/16. That's close to 1/4. That's close to 1/4 because 1/4 out of 16. What's 1/4 of 16? What's 16 divided by 4? 4. 4/16 would be 1/4. So 3/16 is close to that, isn't it? All right. And finally, it says, using estimation, order the fractions from least to greatest. So which one up there is the smallest one? 5/12, 3/16, 1/8, or 1/6? Which one's the
1/8.
smallest? 1/8. Okay, we know the smallest. Then which one is the next one in line? 1/6, 3/16 or 5/12? 1/6. And then which one would then which would be the next? 3/16, and then finally 5/12. And that was all using estimation and thinking about how close it is to a half or a quarter. Nicely done. All right. So down in the next paragraph down, it says sometimes you can use estimation to compare rational numbers. Another method is to rename each fraction using the least common denominator and then compare the numerators. All right, does this sound familiar? Least common denominator. Okay, and it says replace the circle, ED circle, with less than, greater than, or equal to make 5/8, ED circle, 3/4. 5/8 compared to 3/4, a true sentence. 5/8 compared to 3/4. So we're going to rename the fraction using least common denominator. For 5/8 and 3/4, the least common denominator is 8. Why is that? Why is the LCD 8?
Because 8 is bigger than 4.
8's bigger than 4, yep, but why is it the least common denominator? Because
4 goes into 8.
4 goes into 8, that's right, and 8 goes into 8, doesn't it? So we're going to use 8. So they show the 5/8 really didn't need to be built up. It's just multiplied by 1. So it's kind of redundant that they did that, but they're just showing you that they did that. 5/8 equals 5 over 8 times, or 5 times 1 over 8 times 1, or 5/8. Then the 3/4, if we want to build that up to 8, what do you have to multiply 4 by to get 8?
2.
2. So you got to multiply the numerator by 2. So 3 times 2 is 6, 4 times 2 is 8. 6/8, 6 parts of 8 is the same as 3 parts of 4, isn't it?
Mm-hmm.
Okay, so then you look at 5/8 and 6/8. Ah, 5/8 is what compared to 6/8? Less than, greater than, or equal to? 5/8. 5/8 compared to 6/8.
Oh.
Less than. 5/8 is less than 6/8. So you would be able to say 5/8 is less than 3/4. All right. Let's try it with a couple of them. And then, so we got to go through our steps. All right. So I'll put my little camera here in front of you and record this, but I'm going to go right upside down and backwards. All right, there we go. Paige, every once in a while I'm going to say hello and see if you can say anything to us. Yeah, we still don't hear you. Hopefully you still hear us. All right. Okay. All right, here we go. We have 3/4 compared to 7/12. So what you have to do is you have to say, okay, I got to take my 3/4 and my 7/12, and we have to build those up to a least common denominator, right? Now, what is our least common denominator, 3/4 and 7/12? One of the first things you need to do is ask yourself, would one of the denominators work for both of them? So would 4 work for 12? No. But would 12 work for 4?
Yes.
Yes. So 12 is our least common denominator. We want to get 12. So we know 7/12 is going to stay the same, right? But what we got to build up 3/4 to the 12ths. So what times 4 becomes 12?
3.
3. So 4 times 3 became 12. So what do we have to do with that 3? We have to multiply 9. Exactly. So 3/4 is the same as 9/12. Now we start comparing. It says compare 3/4 to 7/12. So 9/12 compared to 7/12. What is that?
7/12 or 9/12 is
greater than, right? So you write your final answer. 3/4. Let me erase this or start a new board. Here we go. So it's asking you 3/4 compared to 7/12. So you figured out, you built up your fractions and said, okay, 3/4 is 9/12. 9/12 is greater than 7/12. Therefore, 3/4 is greater than 7/12. Okay? That help? Paige, hopefully you're following along and that helps. So to recap, we look at our fractions. We have to build up our fractions or change our fractions to rename our fractions to an equivalent, then compare those equivalents, because now we're looking at them as the same, as like fractions, because they have the same denominator. Remember that term from long ago, like fractions? They have the same denominator. So now all we have to do is look at their numerators, and 9 is bigger than 7, so therefore 3/4 is bigger than 7/12. Let's try another one. All right, we have 5/6. Oh, Paige, I hear you.
Now we're getting there.
Woo! Hello. What happened? You there?
I have no idea.
I have no idea. Did it just all of a sudden start working, or is someone there fiddling with it?
I'm fiddling with it.
Oh, good job, Miss Rao. Woo!
It's Mary, actually.
Oh, Miss Mary, good job. All right.
Not gonna give up.
Yay. Okay. So, have you been listening all along, Paige?
Yeah.
Awesome.
I had to step out because I had a emotional fit.
You had an emotional fit?
Yes.
Over not being able to connect?
Well, it's just
Yes.
computers annoy me. Literally.
Computers do that.
Paige, you know what? Sometimes I have emotional fits also.
We all do.
I love how you took responsibility for your feelings this morning. All right, how you doing? Are you feeling better?
Yeah.
Okay, shoo. All right, well, we are doing little letter B, which is 5/6 compared to 7/8.
Okay.
So we need to build up. We
Mhm.
need to rename because we have unlike fractions. We have 6 and 8. So what do we want to build up our fractions to so they have a common denominator? What do 6 and 8 have in common?
They both go into each other.
They don't both go into each other. 6 can't go into 8. 8 can't go into 6. What other number? What common denominator? What common multiple? Can they both? So think.
2.
Well, 2 goes into both of them. That's a common factor. We can't use that as a common multiple. So think about your multiples. So start with 8. We have 8. 6 doesn't happen there, does
8 goes
it?
into 12.
8 does not go into 12.
Or no, 6.
6 goes into 12, but 8 doesn't. Okay. All right. What's another one? You can move on. You can go, okay, 6. So what's that?
3 goes into 6.
Well, 3 is a factor. So let's think about our multiples. So we have 6 is our first multiple. What's our second multiple of 6?
6.
12. Good. What's our third multiple of 6?
16.
Nope. Third
18.
18.
18.
Does 8 go into 18?
Yes.
No.
What?
No.
What? Hold on.
8 does not go into 18.
18.
6 times 3 is 18.
And 24.
24. Does 8 go into 24?
8 can go to 24.
Yeah,
That's
24.
25.
That's right. So we want to build up our fractions to 24ths. We want to build them up to 24ths. All right?
Okay.
So 5/6 needs to be something out of 24. So you got to think, all right, you got to do a lot of little mental mathy kind of stuff. What times 6 is 24?
4.
4. So we got to multiply 5 times 4. Our numerator times the same number.
20.
20. So 5/6 is the same as 20 24ths. So you would rewrite 20 24ths for your 5/6. All right. Then we take a look at 7/8 and we have to build that up to 24ths. What times 8 is 24?
let's see. 7.
What times
8 times
8? 8 times what?
4.
8 times
8
4 is
times 3.
32. 8 times 3, right. 8 times 3 is 24. So we have to do 7 times 3. And what's that?
21, so it'd be 21 over 24.
21 over 24. Okay, so we're comparing 20 24ths to 21 24ths. So which one's greater? To 21. Or 20 24ths is smaller than 21 24ths. So back to our original question where it said 5 6 is what to 7 8ths? 5 6 is smaller than, less than 7 8ths.
So
Take some time.
5 over
Problems
6.
are really, like, they seem really simple
They're not.
because all you got to do is put this symbol in order to get them. No, it's okay. Yeah, 21 24ths is greater than 20 24ths too. You wrote it, yeah. But the original 5 6 compared to 7 8 would be 5 6 is smaller than, yeah. Okay, so these look like they're easy schmeezy, but you got to do a little bit of work to them, right? You got to think about LCDs, you got to build them up, and you got to compare them. All right, let's do the next one. This is an interesting one.
It's a mixed fraction on C.
It is a mixed fraction. We have 1, so just look at it in your book for a second page. You don't have to copy it. 1 and 4/9 compared to 1 and 2/5. Now guess what?
Huh?
I know.
Oh.
There's a trick we can do with this.
What? No, wait.
So we get to ignore the ones.
Oh, we just keep Mr. Ones?
We just keep them because 1 is 1 is 1 is 1, right? We don't.
Yeah.
It's a 4/9. So we don't really care anymore about the ones because they're already they cancel each other out. They're equivalent. We're not worried about them. So we're just going to compare the fractions. We're going to compare the 4/9 to the 2/5. So we need to build up our 4/9 and our 2/5. So we have to find a least common denominator of 5 and 9.
45.
It's 45. That's right. Because 5 is prime, we just have to multiply it by the other number, as long as it's not a factor. If this was a 10, then we'd be able to use 10. But because it's a 9 and they don't have a common factor, we just multiply them together. So we're going to build these two up to 45s. So we have to think about, and then this is where then you can write them once you think about them. So 4/9, we're going to build that up to 45ths. What times 9 is 45?
45.
It's 5, yep. So we do 4 times 5, and what do we get?
45. Wait, 4 times 5. 20.
20, right, Heather?
20.
So 4/9 is 20 45ths. So that's what you would want to write down, Miss Page. 20 45ths.
20 over 25.
20 45ths. 45.
Oh, 45.
9 times 5 is 45.
Okay.
All right. Now we take a look at our 2/5 from our book, 1 and 2/5. We're going to focus on our 2/5. And we had to build it up to 45ths. So what times 5 is 45? 9. Good. So we have to do our numerator, 2 times
2 times
9.
is 18.
18. So our next fraction is 18 over 45. So comparing these, 20 45ths compared to 18 45ths, what is 20 45ths?
20. 45?
20 over 45 compared to 18 over 45, is it greater than, less than, or equal to?
20 over 45 is greater than 18 over 45.
Correct. So we know that 4/9 is greater than 2/5. So when we go back to our original problem, 1 and 4/9 is greater than 1 and 2/5. Okay? So then you'd put a greater than. Then you'd write that out. You'd write the original. You would write the original equation out, original sentence out. You'd say 1 and 4/9 is greater than 1 and 2/5 because you figured it out in your scratch work. You wouldn't want to write 20 45ths is greater than 18 45ths. That would not be the right answer. That's your scratch work. You'd want to go back to your original problem and write out the original one. Okay? So in that big old box there, Miss Alexander, you would put a greater than on the 1 4/9. Okay? Done? All right, let's do a couple more of these. I'm jumping forward. I know, so that's why I'm only going to do one more. Let's see if we can squeeze one more in. All right, ready? Okay. How about 9/25 compared to 3/10? So I'm just making this one up, Paige.
Okay.
9/25. So you might want to write this out. 9/25 compared to 3/10.
5 goes into both 5 and 10.
But it's not a 5. Our least common denominator wouldn't be a 5. We have to find at least. We have to think about the multiples of 25 that 10 would go into. Does 10 go into 25?
Yeah.
No. What's another what's the next multiple?
What's the other fraction?
3/10. All right. So we take a look at this. We have 9/25 and 3/10. What's our least common multiple or least common denominator? 25 and 10. Well, we know 10 won't go into 25. So what's the next multiple of 25? 25, and then what's your second multiple of 25? You have two 25s. What do you have?
40.
50. 50. Will 10 go into 50? Yeah. So we're going to build these up to 50ths. Okay. Now we got to think about 50ths. All right, Paige, are you there with us? Thinking about 50ths? Okay. So what times 25 became 50?
Mm-hmm.
What times 25 became 50?
Well, let's see. 20, so 25.
What became 2?
2.
No, 2.
2 times 25 is 50. So we got to multiply our numerator by 2, right? So what's 18 times, or it's 9 times 2? 18. Okay. So we got to rewrite that fraction 18 50.
Next one's
No.
18 over 50.
Correct. 18 over 50. All right. Now go back to your second fraction, 3/10. What times 10 is 50?
5.
5, Heather. Good. So you multiply your numerator. 3 times 5 is
It's 15.
15. All right. Now when you compare those, 18 50ths compared to 15 50ths.
It's greater.
Oh, 18 is bigger than 15.
Right. So 9. So back on your original equation, what? 9/25 is greater than 3/10.
So 9 over 5.
So we'll do more of these tomorrow. We're also going to do them with decimals and positive and negative numbers.
Oh, so you guys are going to positive negative number land?
Yep. The positive and negative number line does not go away now, ever.
Yes, it does.
No, it doesn't.
Yes, it does.
No, it doesn't.
Yes, it does.
Welcome to pre-algebra. It's like this all the time. All right, so tomorrow we'll do some work with this with decimals and with positive and negative numbers, and we'll practice, okay?
Negative numbers can go
I'm so
away.
glad, Paige, that you got it figured out. Miss Mary got it figured out, and you could join us. So
We are too.
we'll see you in the morning.
We have conferences down here this
You do. So I'm going to see you
Tuesday.
Oh, that's right. So I need to
The
record.
12th.
Okay, so I'm going to record. I'll record the lessons tomorrow, Thursday, and Friday and send you YouTube links, okay? And for practice today, Paige, I'm going to stop this particular lesson and then I'll publish it and send you the link to the lesson today just so you can practice opening up the link and seeing what happens, all right?
Okay.
Okay.
And I'll see if I can talk to my mom about our internet at home.
Okay. Yeah, Ed.
Because we were going to set it up this weekend and then we didn't.
Okay.
We
Not
had
a problem.
we had other stuff to do.
All right. Okay, my dear. Have a good week.
You too, JJ.
All right. Take care.